Welcome to the next video for 4.4 in our trig adventure, trig functions of any angle. This is day 2, and our main idea today are these things called reference angles. Since we're out of the first quadrant, some trig functions switch to positive and negative, and these reference angles are a pretty slick way to figure out the sign and value of our angle. So here, it says the values of the trig functions of angles greater than 90 or less than 0 can be determined from their values at corresponding acute angles called reference angles. So it says here in their definition, let theta be an angle in standard position. Its reference angle is the acute angle theta with that little mark up there, theta prime, formed by the terminal side and the horizontal axis, the x-axis. So think about this. The reference angle is just the quickest angle to get you back to the x-axis. So if we're in quadrant 1, the angle is the reference angle. Whatever this angle is the same, so that would be our same as the reference angle. But here now, look, if we go into quadrant 2, we're out this way, and here's angle theta. The reference angle is this angle that gets you back to the x-axis, theta prime. So if we're in degrees, it would be 180 minus that angle, or if we're in radians, pi minus that angle. Just think how many more degrees or rads to get back to the x-axis. Now let's say here this angle stopped in quadrant 2. What if we continued on and went down into quadrant 3? Well, our reference angle is still the quickest way back to the x-axis. So in this case, since we've gone beyond the x-axis, it's going to be the angle minus 180 or the angle minus pi. Again, just the quickest way back to the x-axis. Now, what if we go all the way around here and get into quadrant 4? Well, if we're in quadrant 4, the quickest way back to the x-axis is not going to be this way. It's going to be, just keep going counterclockwise, this angle right here. That would be our reference angle, theta prime. So again, it's kind of like rounding. We want to round our way back to the x-axis. If we're anywhere in quad 1, our quickest way back is going to be here. That'll be the same angle that we started with. If we're in quad 2, we're going to round it down to the x-axis. If we're in quad 3, we're going to round up to the x-axis. If we're in quad 4, we're going to round up to the x-axis. Notice we're not doing anything to the y-axis. It's always about getting back to the x-axis. That is our reference angle, theta prime. Theta prime. So let's try to find a few here. And I highly encourage, sketching them really helps to see what's going on. So here's my xy axis. If I want to graph 300 degrees, well, let's see. 0, this takes me to 90. I need to go farther. 180, I need to go farther. 270, I need to go farther. So that's going to put me here in quad 4. And this, we've gone 300 degrees around the circle. So how many more degrees to get back to the x-axis? We want to figure that out. Well, a full circle's 360, and we've used up 300 degrees. So here, our reference angle theta prime would equal 60 degrees. Letter B is a little trickier. Notice there's no degree sign, so we can assume that this is in radians. So let's think radians. If we're going halfway around the circle, that's pi. And remember, we can round that off to about 3.14. Half pi up here, that's about 1.52. Pi over 2 is about 1.52. So let's see here, 2.3. That's more than 1.32 or 1.52. It's less than 3.14. So we're opening up this way. 3.14 is here, so 2.3 is a little bit less. We are definitely in quadrant 2. Back, there we go. So we're somewhere here in quad 2. Our reference angle theta prime is this distance back to the x-axis. Well, let's see. That would be, we're going to use our rounded amount here. So we could find theta prime is going to be approximately pi 3.14 minus the angle that they gave us, 2.3. And if we find that as a decimal, that's going to be about 0.8416, approximately 0.8416. Okay, letter C, it's a negative angle. So remember, when we start, we're going to go clockwise, counting by 90s. So this would be negative 90. We need to go farther. Negative 180, we've gone too far. So let's see, we're somewhere in here. Now, let's ignore the negative sign. We want to get back to the x-axis as quick as possible, so it would be this way. Ignoring the negative, remember there's 180 degrees in half of a circle. So we've gone negative 135. We got to keep going a little bit more, and that means we're going to go 45 more degrees. And notice this is positive. Reference angles are always by default positive. It's just the quickest way back to the x-axis. So our negative 135 degrees left us stranded here. The quickest way back to the x-axis is 45 more degrees. So there's our reference angles. Again, it's just the quickest way to get back to the x-axis. Now, I'm not even going to read through that. You can read that in your book. It says here to evaluate the trig function of any angle. To find the value of the trig function of any angle theta prime, I would say first we're going to find the reference angle. Find ref angle theta prime. We're going to get the value from the table. Get value from the table. All our reference angles are going to be in the table. And then 3, it says up here too, depending on the quadrant, affix the appropriate sign. Sign by quadrant, either positive or negative. And remember, we're going to use the good old all students take calculus. These are what is positive where, if it's not positive, it has to be negative. So we're going to find the reference angle, value from the table, positive or negative by the quadrant. And here's the table. From 0 degrees, we got our friendlies, 30, 45, and 60. These are the ones that are going to be our reference angles. And then we've got 90, 180, and 270. So the book says by using reference angles and the special angles discussed in the last section, we can greatly expand the scope of our exact trig values. For instance, knowing the values of 30 degrees means you know the function values for all angles that have a 30-degree reference angle. For convenience, the table below shows exact values for some of our specials. And here I think the book finally points out about the pattern. Learning the table of values is worth the effort because doing so will increase your efficiency and confidence. Here is a pattern for the sine function to remember the values. So 0, 35, 45, 60, 90. All the denominators are 2's. Look at the numerators. Root of 0, root of 1, root of 2, root of 3, root of 4. Remember, this root of 0 is 0, so that just turns into a big old 0. The root of 1 is 1, so that's just your 1/2. And then here the root of 4 is 2, so that becomes 2 over 2, or just 1. But the pattern is there for those numerators, and sine is just cosine in reverse. So cosine would have the same values, but in the descending order instead of ascending, like we get here. All right, let's take these for a spin. So the first one, cos of 4/3 pi. So let's see, here's my xy axes. This would be 1 pi. And if I make this into a mixed number, that's the cos of 1 1/3 pi. 3 goes into 4 one time with 1 remainder, 1 1/3. So if I go this far, this is 1 pi. And if I go this far, that's 1 1/2. And I've gone too far. A third is less than a half. So that's going to leave me right about here. So this is 4 pi over 3. Now, in this case, our reference angle is we're going to back up. We wanted to stop at pi, but we went 1 1/3. So how far do we have to back up? Well, that would just be the 1/3 pi. Theta prime equals pi over 3. Oops, 3. So let's go to the table. So let me write it like this. The cos of 4 pi over 3 is exactly the same as the cos of pi over 3, except the positives and negatives might be off because we're now in a different quadrant. So we want the cos of 4/3 pi. Cos of 4 pi over 3 is equal to, well, let's go to our table and find the reference angle, cos of pi over 3. Well, here's cos. Here's pi over 3, so the value is 1/2. Our value is 1/2. Let's figure out if that's a positive or negative half. So let's go back to my quadrants over here. All students take. So the the quadrant we stopped in, tangent is positive. So that means cosine must be negative by default. So we got -1/2 for that value. Again, figure out the reference angle, get the value from the table, figure out if you're positive or negative by the quadrant. Letter B, tan of -210. So this would be -90, -180. I need to go a little farther. If I go to here, -270, I've gone too far. So this is my -210. I want the quickest way back to the x-axis. Well, let's see. Half a circle is 180, and I went beyond 180 to 210. So to get back, that is a 30-degree reference angle. There's 30 degrees between there and the x-axis. So the tan of -210 degrees is going to have the same value as the tan of 30. The tan of 30 is √3 over 3. √3 over 3. Now let's figure out if that's positive or negative. All students. So the quadrant we stopped in, sine is positive. Tangent, by default, must be negative. Remember, all students take. If we were down here, that would be a positive value. But since we're up here in quad 2, tan is negative in quad 2. Last one here, cosecant 11 pi over 4. Well, if you make that a mixed number, 4 goes into 11 twice without going over, and there's a remainder of 3, 2 3/4 pi. So here, if I draw my xy axis, one lap around will be the 2 pi, and now we're going to go 3/4. Well, here's a half, and if we go this far, we've gone too far. That would be 3 pi. So we're going to back up to about here. So there we've gone around 2 pi took us once around. The 3/4 took us this much farther. So how much more to get back to the x-axis? Well, think about it. This is the denominator 4. So our reference angle will have a denominator 4. This is a half. This is 1, so that's right in splitting that difference. That's going to be 1/4 pi. So this is 3/4. We need one more fourth to get us back to the x-axis. So our angle theta prime is pi over 4. So this cosecant of 11 pi over 4 is going to be the same thing as the cosecant at pi over 4, but we might need to change the sign. And when we go to the table, cosecant is not on the table, so we're going to find the sign at pi over 4 and flip it. So here is sine pi over 4. We're going to turn that upside down, so that's going to be 2 over the root of 2, and we are going to rationalize 2 roots of 2 over 2, and then the 2's cancel. So the cosecant of 11 pi over 4 is equal to √2. Let's figure out if it's positive or negative. So remember, we stopped here in quadrant 2. Let me just rewrite it here. Our angle stopped here in quadrant 2. all students. Sine is positive, and if sine is positive, so is its reciprocal. So we would turn, or that would also be positive. Okay, let's see what we got next. Here we got one of our clues. Theta is an angle in quad 2, and sine is 1/3. They want us to find cos and tan just by using the identities. So I'm going to set it up like this. We know our angles in quad 2, so I'm going to draw my angle opening into quad 2. And we know that sine is 1/3. And notice this is all students. So in this quadrant, yes, sine is positive. So sine is 1/3. We want to find the cos, and we want to find the tan. Now, it's very easy to forget to figure out if they're positive or negative, so let's do that first. So here we are in quadrant 2. Sine is positive, and so is its reciprocal cosecant, and that means everything else is going to be negative. So when we find cos, it's definitely going to be a negative value. When we find tan, it's also going to be a negative value. And they did tell us to use the identities. So let's go to the, start with the Pythagoreans. We've got sine and we want cos. So sine squared plus cos squared equals 1. Well, we got sine is 1/3. If we square 1/3, we get 1/9 plus cos squared equals, I'm going to make 1 into 9/9. And then if we subtract 1/9 from each side, that becomes cos squared, that's supposed to be a squared, equals 8/9. And if we square root, the cos of theta is our denominator, 9, square roots to a 3. And then our numerator, the root of 8, we can simplify that into 4 times 2, or 2 roots of 2. And here's cos. I put my red negative sign there because we found the value, 2 roots of 2 over 3, and we've already established that that is a negative value. Now the last one, we already know tan's going to be negative, and tangent is the same as sine over cosine. So my sine is 1/3. I'm going to divide that by 2 root 2 over 3. And of course, if we're dividing two fractions, we're going to bring it up, flip it, and multiply. So now that's 3 over 2 roots of 2. And I'm sure you see on the diagonal, we're going to have a cancellation of the 3's. So we're left with 1 over 2 root 2. And we are going to rationalize. Now our denominator is a 2 root 2, but to rationalize, we're just going to multiply by a root of 2. Root of 2. So our numerator up top is a root of 2. And then here, when we multiply these two radicals, we'll get a 2 times another 2 that's already there is a 4. Root of 2 over 4 is our tan value, and we've already figured out that it's negative. So negative root of 2 over 4. All right. Again, make sure you figure out if they're positive or negative. I would encourage you do it first because it's easy to forget if you save it for the end. All right, these are just calculator problems. The first one is 410. So on the calculator, I'd type in the 410. If you're using a TI-30, there is no cotan key. So we would do the tan of 410, and then we would flip that with the 1 over x key to invert it. And that is approximately, I'm going to round to 4 spots, 0.8391. 0.8391. Letter B. I do not see a degree symbol, so I'm just going to say it's in radians. Change your calculator to rad mode. On the TI-30s, you'd hit the 7 key first, and then the negative, and then you'd hit the sign key, and that turns out to be approximately negative 0.6570. 657. The last one here, we've got a pi in it, so that's a dead giveaway. This is in radians. Now, secant is not a button on the TI-30, so to type in the order of button pushing, You're going to hit the pi key. You're going to divide that by 9, and then you're going to hit equals, because we need to do what's in the parenthesis first. Pi divided by 9 equals, and then since secant is not on the calculator, we're going to hit the cos key and flip that answer with 1 over x. So pi divide 9 equals cos. Invert that, you should get approximately 1.0642. And there's our calculator fun. All right, some for you to try on your own. Pause the video and then, of course, start it back up and then see if you got your answers right. Okay. Find reference angle theta, sketch it in standard position. So this isn't bad. Degrees are always fun. It's positive. We're going to go counterclockwise. 160. Here's 90. Here's 180. We've gone too far. So we're going to back up. So here is 160 degrees. Our theta prime, our reference angle, is how many degrees to get back to the x-axis. Well, we've gone 160. We just got to go 20 more. 20 degrees. So the bigger angle here is theta. This reference is theta prime. Now here we're going to find this without a calculator. So the steps are going to be find the reference angle, value from the table, positive or negative based on the quadrant. And here they're talking 3 of them, sine and cos and tan. So first, let's find our reference angle. So I like to sketch it. So here we go. 90 degrees, we need to go farther. 180, we need to go farther. 270, we've gone too far. So we're going to back up, and that puts us here in quad 3. So we've gone 225, and we want to back up. And when we back up, remember where we're backing up to is 180 degrees. So we can just subtract 225 minus 180. Our reference angle, theta prime, is 45 degrees. So now I'm going to come down here and do a list. We're going to do the sine of 225. We're going to do the cos of 225. And we're going to do the tan of the same 225. And we're going to get the values from the table because of our reference angle. Theta prime is 45. If you flip back to the table, the sine at 45 is root 2 over 2. The cos at 45 is also root 2 over 2. The tan at 45 is 1. So now let's figure out what's positives and what's negatives. All students take. We stopped in the quadrant T, so tan is a positive answer. And then that means everything else must be negative by default. Okay, good stuff. Good stuff. Finally, what do we got here? They give us a function, and they tell us what quadrant we're in, and they want the trig value of this other one. So let's see. We're in quad 4. That would be here. All students take calculus. The C stands for cosine. So when we solve this, our answer is going to be positive. Just based on our quadrant. If we're in quadrant 4, cos must be positive. And because we're looking for cos, and they gave us sine, let's do Pythagorean. Sine squared plus cos squared equals 1. Well, if I put my sine in here, that's negative 3/5, and we're going to square it, plus cos squared equals 1. So if we square what I have in the parentheses, we're just going to, well, a negative times a negative is a positive, and we square the numerator and get a 9, and we square the denominator and get a 25, plus cos squared equals, let's get our common denominator right now. Let's make it 25/25. Oops, chopped off my 9 there a little bit. All right, let's get the cos squared alone. So we are going to subtract cos squared theta equals. So bring over the 9/25 and minus it. 25/25 minus 9/25 is 16/25. Ooh, and that's just beautiful because when we square root the left side, we're just left with cos. And the square root of the numerator is a 4. Square root of the denominator is a 5. And we've already figured out that it's positive based by the quadrant. So the cos is 4/5. Very nice. And I think that is our last problem. Yeah. I will see you in Microsoft Teams tomorrow or in class, depending. And we will do some odd problems based on 4-4 day 2.